Am I recording? Yes, I'm getting audio. So let's go over insertion sort. So insertion sort basically works like this. We assume that the leftmost side, which ends at array of 0, is our sorted portion, and everything to the right side of that is our unsorted portion. So index 0 is our sorted, and 1 through 3 is our unsorted portions, because array start at 0, 1, 2, 3, so 1 through 3. And so we want to compare, so we're gonna have two variables, I and j, and we want to just compare those variables. I can't talk today. So we're gonna compare, is 1 less than 3? It is. So 1, 3, so we swap them, so it's 1, 3, 5, 2. So now this is our portion and unsorted portion, because we can see this is ascending order and this is not. You could say it's descending order, but it's just in this case it looks like it would. We can just assume that this is unsorted. So now this is our first pass. Our second pass, we're gonna check, is 5 less than 3? It's not. So we can just keep it how it is. 5 less. Yeah. Well, you check it here and then we move on here. But so it's 5 less than 3? It's not. So since this is already in ascending order, that means we don't have to check anything on the left side of this border, you can call it. So now it's just 1, 3, 5, 2. So we kept it the same, but we increment I. So I is basically our border here. And then our next pass, we're gonna check, is 2 less than 5? So is 2 less than 5? It is. So it's not. So now it's 5, 2. Well, that shouldn't be there. We're gonna check, is 5 less than 2? Is 5 less than 2? Is 2 less than 5? It is. So it's 1, 3. We swap these, so it's 1, 3, 2, 5. But now since we did swap, that means we are able to actually compare anything to the left side of the sorted array. Because now we see that this is not in ascending order no more. So now we're going to compare 3 and 2. So it's 1, 2, 3, 5. But 2 is not less than 1, so we just keep it how it is. So at the end, this is our sorted portion after this I goes at the very end. So this is my pseudocode, I guess you can call it. So we're going to start at index 1, which is I. We're going to loop through the array, so 1 through 3. Make a variable j starting at I minus 1, so it's always going to start at 1 less than I. And then we're going to compare elements. And if we need to, like on this case, we're going to decrement j while not going out of bounds and still comparing all these elements. And that's how basically insertion sort works. Let me show you my code for this. So here I made a swap function to swap array elements, and then, or you could just call the C++ library and swap function. So we're gonna have insertion sort, and it's gonna take in an array, and then this is just gonna be our size of the array. We're gonna start at 1, like how we said in the pseudocode. We're gonna loop through the array, so I less than n, I plus plus, and then we're gonna make a variable j, like how we said. I minus 1, but I like to keep it more. For me, it's easier to read when it's like this. So then we're gonna make a while loop. You could make this in a for loop, but a while loop for me looks better here. Check, is j greater than or equal to 0? It is, right, because it's starting at 1 first pass. And then we're gonna check, is array j minus 1, what's it called? J minus 1 is the element, is the index 0. So is index 0 greater than index 1 in this case? Well, from our example, it was. So we swap, and then we're going to decrement. And then you keep doing that each time. So the I, we're going to increment I, so we get this border, we get this border, we get this border, etc. And for in this case, when we had to swap 2, that's why we're decrementing J all the time, so it swaps each element that it needs to. And then we print our print function. So we just go through the whole loop and just see all the contents of the array. And then I just made my size bigger just in case we want to add more values, which it's just 4 right now. So we're calling insertion sort and print. So we see we get the same thing: 1, 2, 3, 5. 1, 2, 3, 5. So the time complexity of this algorithm varies. So for example, if everything's already sorted, that means that we're not gonna check everything on the left side of the array. So for example, here we didn't have to check, since 5 is less than 2, we didn't have to go through this. So we're gonna keep, so basically a sorted array, the best time complexity is just O of n. I mean O of 1. Because we're not doing anything, we're just comparing. And if we did have to swap, that means the time complexity is O of n, because we had to swap every single element in the array. And then we still have to go through the outer array, which is just O of n. And this is just O of n. Because we still have to go through each array element. So like our border. So at the end, we just could get O of n. And this is just O of n squared. This is just comparisons and just outer loop for the just a comparison for the inner loop and outer loop going through the array. Well, no, this is comparisons of the inner loop, and this is just going through the array and the outer loop. So it all leads up to this. So we just multiply them. And yeah, that's insertion sort. Oops, I'm not using that. Bye.